Okay, this is a 3-1, like 3 terms. So what is A?
1.
What is B?
1.
What is C?
1.
Okay, so since A is 1, I'm looking, I don't have to worry to do that. So I'm looking for a number that when I multiply, I get 1, and when I add them, I get 1. So what are the factors of 1? 1 and, well, 1 times 1 is, 1 times 1 is 1. What is 1 plus 1?
2.
That does not equal 1. Are there any more factors of 1?
Negative 1.
But everything is positive. So, are there any more factors of 1? This is what we call a prime 1. Because it cannot be factored. So if we went to solve it, we would have to use the quadratic formula to solve it. Okay? And it also means that our roots, our zeros, are not real. This is anytime you get a prime 1, it means that our roots or our zeros, solutions are not real. And this one will never cross the x-axis.
If they were all 2, would it be like a prime 2? 2x, 1, 2x.
No, because, well, it depends. 2 times 2, yes, if we would have multiplied them all by 2, it would have been prime still. The only thing is they would have all had a 2 in common, and we would have pulled out a 2 before we did it. Yes?
If they all have the same number in common, will it always be prime?
Yes, but you wouldn't write prime. Like you would pull out the 2, and then it would just be left with 2 times x squared plus x plus 1. So, any other questions? Okay. Now we're going to example 4, that one right there. And there. Can you guys see that? Okay. This is another problem that SAT, ACT, PERT, anything loves these types of problems, okay? So notice that my exponent is even. This is what we're going to spend the rest of our day really focusing on, is this one. Notice that that exponent is even, okay? And notice that 1 is a perfect square. So there's a couple things that you need to notice about this. Anytime you have an exponent that is even, and the number in front of the x is a perfect square, and the number after the x is a perfect square, and there's a subtraction sign, this is what we call a difference of squares. So what is half of 4? This is why you need an even exponent. What's half of 4?
2.
So I'm going to have x squared. And then what's the square root of 1? And a difference of squares, you're going to have a positive and you're going to have a negative. That's what makes it a difference of squares. Okay? So x to the 4th minus 1 factors out to x squared plus 1, x squared minus 1. And the reason that works is because my exponent was even and the 1 is a perfect square. Now, before, in chapter 4, when we did this, we would be done. But now we have to go back because we still have an even exponent. I have an even exponent. 1 is perfect square, but what's in the middle? A plus sign. Can't factor it. So we're going to go to the next one. I see an even exponent. I see a subtraction sign. And I notice that 1 is a perfect square. This means that we still can factor that. We're going to leave x squared plus 1, and then we're going to we're gonna factor x squared minus 1. It's called a difference of squares. Half of 2 is 1, so I'm going to have an x plus, what's the square root of 1? 1, and then I'm going to have an x minus 1, and that's my final answer. So you need to pay attention to, so first thing, do they have anything in common? Then if you see only 2 terms, you have to determine, is it a difference of squares? Those are really important things that you need to notice. So what questions do you have? Yes?
Why can Alan split the 2 blue?
because it's a difference of squares. So this is a perfect square, it's subtraction, and this is a perfect square. This is not a difference of squares. There's no way you can multiply and not have a middle term with a positive number. If I do x times x, I get x squared. That middle term will cancel out when I multiply it. Yes?
What happens if the exponent is odd?
Then you can't do it. So we're going to talk a little bit about that tomorrow with odd exponents. Today we're really, most of our problems are going to be centered around that difference of squares. Any other questions?